Now let's define what's called an equilibrium constant. Now the equilibrium constant specifically is defined for a reaction in the gas phase. So let's consider a gas phase reaction. Where we have reactant A and product B, and the reaction is at equilibrium, so the pressures of A and B are constant. So define the equilibrium constant as being the pressures of the products multiplied together divided by the pressures of all the reactants multiplied together. So we can write this as the pressure of product B. We're going to divide by a standard pressure, and we'll raise it to the B power. That's a way of multiplying them all together. And then we have the pressure of the reactant A divided by a standard pressure raised to the A power. So this is the equilibrium constant. Now you can see that it's unitless because all the units cancel since we are dividing by a standard pressure. The reason we divide by a standard pressure is to make it unitless. Now the standard pressure is equal to 1 atmosphere, so all we're doing is canceling units. We're dividing through by 1, which doesn't change the value of Kp numerically. Now since we're lazy and we don't like to write as much, we normally leave out the standard pressure just so we don't have to write it, but we realize that we've just not written it, so the units will still cancel. So we, in our lazy way, we would write the equilibrium constant in this term, this form. So we do this in practice, leaving out the standard pressure, but realizing numerically it's the same, but the units don't all cancel if A and B are different. But we just neglect that fact because we're just writing like this for convenience.